drawn the diagram also. We had also discussed why we need inert gas and how it has made the tankers safe, how it has changed the atmosphere in the cargo tank, and the safety measures, how the life has changed on board after inert gas system, and how the inert gas from the boiler uptake goes through a treatment and it is cooled, cleaned and dried, and after that, once the oxygen percentage is less than 5%, it goes to the cargo tank. So now today, any question before I proceed further? Whatever we have learned so far. Okay, now we understood the importance of the inert gas. It made the life of the people on board safe on tankers, which earlier people used to call it a live bomb which can explode at any time. SOLAS came out with the requirement that if you are installing the inert gas system, what are the following requirement has to be complied with, and this inert gas system has to be approved by the administration. So as per the SOLAS, inert gas system shall be so designed and operated as to render and maintain the atmosphere of the cargo tank as non-flammable. First and foremost, they say if you are having an inert gas system on board, it should keep the atmosphere of the cargo tank as non-flammable at all times, except when we need to gas free. If as per the operator, as per the ship master, if he wants to gas free for some reason or the other, or the ship is going to the dry dock where we need to gas free all the tanks. Otherwise, the atmosphere in the cargo tank should be non-flammable at all times. Required this inert gas system, they made it mandatory for all tankers above 20,000 deadweight and above. And for the new tankers, after 1st January 2016, they reduced the deadweight from 20,000 deadweight to 8,000 deadweight. Any ship 8,000 deadweight and above carrying a volatile cargo must have an inert gas system. Volatile cargoes are the cargoes which has a low flash point. The flash point of the cargo is less than 60 degrees Celsius. So any vessel of 8,000 deadweight and above carrying a low flash point cargoes of less than 60 degrees Celsius must have inert gas system fitted on all new oil and chemical tankers. After must for the cargo, it's irrespective of the size of the vessel.
Okay, sir.
Right. So it is, if any tanker carrying a cargo of less than 60 degrees Celsius must have an inert gas system. That's why you must have noticed bunker tank, bunker barges which are coming alongside your vessel, they don't have inert gas system installed on those ships. Reason being, the flash point of the bunker is more than 60 degrees Celsius. The system, the IG system, the system that they are talking about is the IG system, shall be capable of maintaining the atmosphere in any part of the cargo tank with an oxygen content not exceeding 8% by volume. So inert gas system should be such that it should be capable of maintaining atmosphere in the cargo tank less than 8% of oxygen by volume at any part of the cargo tank. The system shall be capable of delivering inert gas to the cargo tank at a rate of at least 125% of the maximum rate of the discharge capacity of the ship expressed in volume. Meaning, if my maximum rate of discharge of my ship is 100 cubics per hour, the inert gas system should be capable of delivering at least 125 cubics per hour of inert gas to the cargo tank, so that it's always a positive pressure in the tank. Secondly, there is sufficient inert gas in the system, in the cargo tank. And thirdly, there is no chance of the air from outside to get into the cargo tank. So capacity of the inert gas blowers or inert gas system should be such that it should be at least 125% of the maximum rate of the discharge capacity of the ship expressed in volume. That's why I gave you example. If the maximum capacity of my ship is 100 cubics per hour, then inert gas should be able to deliver 125 cubics per hour, 25 cubics extra. The system, the IG system, should be capable of delivering inert gas with an oxygen content not more than 5%. Earlier it said the cargo tank percentage of the oxygen in the cargo tank should be less than 8%, but the system itself should be capable of delivering inert gas with an oxygen percentage less than 5%, not more than 5% by volume. So when it is delivering at 5% or less, then only it can maintain the atmosphere in the cargo tank as 8% and less of the oxygen by volume. Inert gas supply may be a treated flue gas from the main and auxiliary boilers. That's the diagram that we have drawn other day. That is treated. That is a smoke that is coming out, the exhaust that is coming out from the boiler or auxiliary boilers. That smoke has been treated properly. It's gone through some cycle and it's been cleaned, cooled, and dried and all. And it has gone through the process. That's why it's called treated flue gas. So SOLAS allows that inert gas from the boiler exhaust or after the treatment can be used. Or the flue gas from some ships, they have a IGG, inert gas generators. You can have inert gas generators also on board. Instead of a system using stored carbon dioxide shall not be permitted. So stored carbon dioxide in the bottles, you cannot use those as a inert gas. Flue gas scrubber shall be fitted, which will effectively cool the scrubber should be installed so as to cool and clean the system, clean the inert gas which is going to the cargo tank. So either you can have a treated flue gas or you can have an inert gas generators, but you cannot use the stored carbon dioxide in bottles as an inert gas.
Sir, why cannot we use carbon dioxide from stored bottles?
Usually they use nitrogen as a chemical tankers also, because carbon dioxide you need a storage space for that, and whereas and it will be expensive, it will be occupying some space on board. Maybe carbon dioxide, excess percentage of carbon dioxide might react with the cargo, and carbon dioxide is also used for firefighting. So SOLAS doesn't allow to store the carbon dioxide bottles on board for inert gas purposes. Okay, and a scrubber tower should be installed to cool the inert gas or clean the inert gases which is going towards the cargo tank. There is a requirement for inert gas blows also as per the SOLAS. Blows in IG plant must be the fan which is written there in the diagram. If you look at the diagram, fan, those are inert gas. Blows in an inert gas plant must be approved by administration. Those blows must be approved by the administration and must comply with the following. Minimum 2 blows must be fitted. The capacity of both the blowers together must be 1.25 times the overall capacity of the cargo discharge system. Again, if the total capacity, total discharge rate of the ship is 100 cubics per hour, maximum cargo discharge rate is 100 cubics per hour, then both the blowers combined together must deliver 125 cubics per hour, not single blower. Both blowers together must deliver 125 cubics or 1.25 times the overall capacity of cargo discharge system fitted on board.
सर अगर एक ब्लोअर खराब हो गया तो डिस्चार्ज कर सकता है सर?
दोनों खराब हो गए, एक खराब, हाँ एक खराब हो गए, yes you can discharge, but you will not discharge to the capacity. You will not discharge to your maximum rate. You have to reduce the discharge rate also so that your blowers can cope up with the discharge quantity which is going ashore, so that the positive pressure can be maintained in the cargo tank. Okay.
सर अगर एक सिंगल ब्लोअर की कैपेसिटी पूरे डिस्चार्ज सिस्टम से 1.25 टाइम्स है तो सिंगल ब्लो यूज कर सकते हैं?
These are the minimum requirement as per the SOLAS. You can exceed the minimum requirement. Usually on most of the tankers, you have each blower has a capacity of 1.25 times the cargo discharge of the cargo discharge system. Each blower. But SOLAS requirement is this: if you can comply with this, they are happy. If you can go more than that, they are still happy. But definitely not less than that. And if you are one of the blowers, suppose both the blowers capacity is 1.25 times the cargo discharge system, and if one of the blower is not working, then second blower whatever is the capacity of that blower, you should be discharging less than that so that positive pressure can be maintained.
Okay, sir. Sir, when we are discharging at a lesser rate than the supposed maximum rate, what needs to be done if in this case one blower has malfunctioned and only one is operating? So we will inform and get it repaired whenever possible, latest. But how will the people who have formed these regulations, they will come to know, or what
They will not,
problems can we face in case
no,
it
they
is
will
not
not,
repaired?
if it is not repaired, you will be discharging at a slower rate. Terminal will
We can
definitely
continue
put,
like that.
you have no choice. You have to maintain a positive pressure in the tank and you have to discharge at a reduced rate. You have no choice. And terminal will come wherever you're discharging. The terminal will definitely ask you why you cannot discharge. And they have to know the reason why you cannot discharge your capacity. Whether your boiler is not working properly, whether your cargo pumps are not efficient enough, maybe the IG system is not working. You have to tell them. You cannot keep it to yourself. And these are the safety items. And terminal has a full right to ask you whether you have arranged the technician to repair this or not.
Okay, sir.
What are the steps being taken to rectify this problem, right? And of course they will issue the letter of protest saying that your such and such system, your discharge rate is not your capacity.
Yes, sir.
Okay, the whole world will know. SOLAS doesn't have to know about this. Or if the vetting inspector or the PSC inspector is on board, he will definitely ask why you are not running their cargo pumps to your capacity. You understanding what I'm saying? Because you are comparing rates from the terminal every hour.
Yes, sir. In such a case, the rate of discharge will be lower, and the
Very
terminal will
less.
also get to know. LOPs will be lodged, and in case of a vetting inspection, they might lodge an
An
observation.
observation, yes. Even a PSC also will put an observation. They will not detain the vessel,
Okay,
but they
sir.
will put an observation saying that you must repair it within 15 days, 10 days, here only. Have you done any arrangement? What are the corrective measures being taken? Since you are aware of this problem, if the problem was already there out at sea, what arrangement has been done? Have you arranged a technician? Is the technician coming in this port or next port? Whatever. So they will ask for the corrective action being taken. What are the plans being done to repair this? Because when you're discharging at a slow rate, your port stay also increases. So you're paying more, your port dues also you're paying more. And with this, the other ships are also waiting longer, occupy the same terminal. So you're delaying the terminal also in the process. So many things are getting affected. So these days, you cannot hide all these things. You cannot. You should not also. If it is not working, it's a mechanical thing. Machinery has to give way. But what corrective action are you aware of this problem? One. Second, if you're aware what action has been taken, and they'll be happy with that. And if you try to put abhi hua hai sir, 1 hour before it just happened, everything was okay, blah blah, and if some chief officer, they try to act smart, they increase. When the vetting inspector is there, they try to, god knows, they do all this jiggery booggery, they try to impress, but fact will remain. Discharge rate from the terminal, they will come to know immediately that you're not discharging to the capacity, you cannot fly them. All right, so most of the time the inert gas blowers, that's why each blower is, that's why the ship owners usually they comply minimum, this is the minimum requirement, but practically on board each blower has the same capacity, 1.25 times the cargo discharge capacity, so that in case one blower is giving problem, at least nobody will come to know your discharge rate is maintained. Okay, some ships they have one blower only, it's allowed. You have to take a permission from the administration, from the flag state, but when they put the condition, they put extra spares has to be there in case something happens to this blower, you cannot do anything. So a lot of spares must be there to, so that you, in case any problem, you should be able to rectify immediately. And that one blower must fulfill the requirement as stated above. That means 1.25 times the total discharge capacity of the ship. But usually, very rarely you come across only one blower is there. But usually, it's good for the ship owners also to have two blowers of each of 1.25 times the total discharge capacity. There should be a shut-off arrangement must be provided in the suction and the discharge connection side of the blower. तो blower के suction side में and the discharge side में there should be a valve which should be closed when not in use. Generally, the blows used for gas freeing, hence an air inlet with the blanking arrangement must be provided. So these blowers, we can use it for gas freeing also. So air inlet line must be provided. This is the SOLAS requirement. At a normal operation, this air inlet line must be blanked and it is to be secured. Other day somebody had asked me about the same diagram. Air intake line, you see this? This is the air intake line which can be used for gas freeing purposes. If my IG system is not working and if I have to gas free one of the tank for repair, for inspection or something, then I can use the same system using the air inlet line and putting the fresh air here, passing it through the fan and going to the cargo tank. You can start gas filling the tank using the same system. SOLAS also allows this, but it says that if not in use, this air inlet line, intake line must have a blank. It should be blank when not in use. Reason being, suppose I am running the inert gas IG system, and if this is leaking, the fresh air is getting into the system and unnecessarily it is increasing the oxygen percentage of the inert gas, which will be difficult to detect. So that is why they say you have to be absolutely positive that no leakage is taking place, no ingress of air is happening. That's why SOLAS also wants you to put a blank here when not in use. It is usually on the funnel deck, and one of the decks are there. You will see air intake. If you're not seeing, next time when you go on board, have a look on a funnel deck. You will see a vent kind of a thing. That is it will be stenciled over there, IG air intake line.
Yes, sir.
So that is the line which is connected to the connected to the IG system and can be used for gasoline purpose, and it should be blanked otherwise when not in use.
Sir, this vent is just like a gooseneck or something like that?
It is about same size as the IG line. It's around a pipe and it's got a big blank there. That is maybe butterfly nuts there. It's properly shut on the funnel deck. Okay. Next time when you go on board, the same platform where you have the IG system in the engine room, go out on that particular deck, on that funnel deck, you will see that line, and it will be stenciled, it will be marked there. Okay, the use of this is, and that is necessarily to be blanked when not in use. Okay, so other day somebody was asking me what is the purpose of this. Now SOLAS, now we know what is the purpose, and SOLAS also allows us to have this line which can be used for, so that you can use this same IG blowers for gas freeing purpose also. Okay, so generally the blowers are used for gas freeing, hence an air inlet with the blanking arrangement must be provided. At normal operation, blanking arrangement is to be secured. Normal operation means when you're using an IG system, when you're putting it as an IG mode, then this line must be blanked and secured. All cargo tanks are pressure tested to certain pressure. These IG blowers must not exceed the test pressure, else the tank will get damaged. So it should not pump in so much of pressure, so much of inert gas that it will reach a stage in the cargo tank where it can damage. The pressure should not be so much that it can create a damage in the cargo tank. So the blowers are designed not to exceed the test pressure of the cargo tank. Minimum pressure to be maintained by the blower is about 200 m water gauge in the cargo tank. If you're discharging cargo, and if your IG blowers are not coping up, pressure is reducing slowly, and if it has reached 1200, it will give you the alarm, low pressure, and further it will go at 150, it will give you a low pressure. Still, if you don't pay attention and continue to discharge, if the pressure reaches 100, it will trip all the cargo pumps. So that mechanism is also provided. IG system is connected to the cargo pumps also. In case the IG pressure is going too low and you continue discharging at certain pressure around 100 m water gauge, the cargo pump will also trip because it is connected. The signal goes from at 100 m water gauge. The signal goes to the boiler to stop the boiler because the IG system is not coping up. This is to avoid going into the negative pressure in the cargo tank. Safety device. And the IG blowers are to maintain minimum of 200 mm of water. There must be a high temperature alarm at 65 degrees Celsius and a high temperature trip at 70 degrees Celsius to safeguard the blower. If my scrubber tower is not working, as we know, very hot gases come from the boiler uptake, goes to the scrubber, and somehow if the scrubber's outlet where in the scrubber this is cooled, these temperatures are brought down as close to the seawater as possible. Seawater temperature on an average is around 30 degrees. So temperature of the IG comes to around 35 to 40 degrees Celsius. If in the scrubber tower, if the temperatures are not coming down, that means the scrubber tower is not working properly. So the hot gases will come out from the hot inert gas will come out from the scrubber tower, goes to the blower. And if the temperature of those gases is 65 degrees, it will give you the alarm, high temperature alarm. And even if we don't do anything, if the temperature keeps on increasing around 70 degree, it will trip the system, it will stop the blower. High temperature. Firstly, we are not allowed to send such a hot gases to the cargo tank, and secondly, to safeguard the blower. Otherwise, these hot gases will damage the IG blowers. So to protect the system and to protect the atmosphere in the cargo tank, avoid sending the hot gases in the cargo tank. The trip has been installed. It's a requirement as per the SOLAS. It will shut down the blowers unless and until you repair the scrubber tower, cool down the gases in the scrubber tower, then only the system will be able to start again. Driving media of the blower can either steam or electrical. It is electrical, but some ships you may come across as steam. The driving force, how the running of the blower, usually it is electrical driven. Some ships you do come across where it is steam driven. And lastly, the blowers must be located at the aft of the cargo tank and the cargo pump room of the ship. Usually these blowers, the whole IG system is in the engine room, which is aft of the cargo area and also of the, so SOLAS also requires that these blowers must be aft of the cargo tanks and aft of the cargo pump room. So these are the requirement for the blowers, IG blowers. Any questions so far? Okay. So if you look at the diagram, after the IG blower is a gas regulating valve. As per the SOLAS, shall be fitted in a inert gas system. It shall also be capable of automatically regulating the flow of air. There is a provision provided where we can set the pressure in the cargo tank by the operator. Usually is done by the chief officer. He sets the pressure, maybe around 500. I don't want more than 500 and water gauge in the cargo tank. He sets the pressure. There's a knob there, he will set the pressure there, and this regulating valve, this gas regulating valve will start operating. It will function in such a way, it will maintain that set pressure in the cargo tank. It will keep regulating the flow of inert gas, how much inert gas is required to go on deck to maintain that pressure set by the operator. Once that pressure is set, this regulating valve starts functioning. And if it reaches the 500, for example, I'm just taking an example of 500 and water gauge. If it reaches that, it will close the supply towards the cargo tank and allow the gases to go up to out from the funnel because it's not needed in the cargo tank. And once the pressure drops, it will crack open the supply to the cargo tank and it will start slowly closing the funnel valve so that the pressure can be maintained in the cargo tank. That is the function of the gas regulating valve. It also works when the oxygen percentage is high. When the oxygen percentage is 8%, it will give you the alarm. And if it is less than that, if it is 5%, it will give you an alarm. And when it reaches 8%, it will stop the IG going towards the tank and it will go out from the funnel till the oxygen percentage is brought back to 5% and less. Once it is less than 5%, automatically the gas regulating valve will function. It will allow the gases to go towards the cargo tank and it will shut off the supply for shut off the valve which is going to the funnel. That's how the gas regulating valve functions. So it's a SOLAS requirement that gas regulating valve shall be fitted in the inert gas system. It shall also be capable of automatically regulating the flow of inert gas to the cargo tank. If you look at the diagram, after the gas regulating valve, the IG pipeline, IG main enters the hazardous zone. Till now, it was in a safe zone, and now enters the hazardous area as deck. On the deck, once it enters the hazardous area, there should be two non-return devices, one of which shall be water seal, shall be fitted in the inert gas system. It's a requirement for the SOLAS to put the non-return devices in the system. Reason being, cargo vapors from the cargo tank should not go to the engine room or should not go to the safe area, because that is a safe area. That's why it is a safe area. That's why we are running so many machineries there. We are doing hot work. These machineries are generating so much of heat. We are running boiler. We are doing hot work because it is safe to do that in that area, because there is no cargo vapors there. So only thing is missing there is cargo vapors. Once we allow these cargo vapors from the cargo tank to go to the engine room, my fire triangle will be completed, because there is sufficient oxygen in the engine room, there is sufficient heat in the engine room. Only missing item is the cargo vapors. So if I don't have this non-return devices installed in the IG system, the cargo vapors, when the IG system is not running, out at sea, cargo vapors which are always present in the hazardous area can go to the engine room, complete the triangle, and can have a fire and explosion, because there's enough amount of heat is there, surplus amount of oxygen is there. Only missing thing is the cargo vapors. If I don't have this non-return devices, these cargo vapors which freely enters the engine room and completes the fire triangle. So to avoid that, under no circumstances, this used to happen when these non-return devices were not there in the system. When initially this IG system was installed on board, couple of ships, they had a massive explosion. They were wondering why this happened. Everything was okay, and then they came out with this vapors from the cargo area has traveled all the way to the boiler, and there was a massive explosion has happened. So under no circumstances we can allow these vapors from the cargo area, which is flammable, which is volatile, to enter into the safe area. So we have to be absolutely sure my non-return devices should be capable of restraining, stopping these vapors from going to the engine room. So that is why the SOLAS has a requirement of at least two non-return devices, two, not one, two non-return devices must be installed in the system. If one fails, at least second will work. And out of these two, one should be a water seal. That's why you have a deck seal. Why water seal? Because water seal is guaranteed that it will definitely not allow the vapors to go back to the engine room. Whereas if you have a mechanically operated non-return valve, with time, since the IG has an acidic in nature, it eats up the metal, it eats up the rubber coating, it eats up the rubber packing. So with time, this mechanical non-return valve will start leaking. So you cannot trust this mechanically operated non-return valve 100% that it will never leak. That's why, whereas that water seal, irrespective of the time, irrespective of the age of the vessel, this water seal will work at all time, will maintain the seal. So that's why SOLAS needs, you must have a two non-return devices, and one of which should be a water seal and must be fitted on the IG main. The above devices must be located on the cargo area on deck. So the deck seal, these non-return devices must be must be fitted on the deck area, hazardous area, not in the safe area, hazardous area. And the water seal shall be capable of being supplied by two separate pumps. So when you have to maintain this water seal, this water level in the deck seal has to be maintained. We look at the diagram. This is the deck seal. This is the water supply, seawater supply. It is maintaining, this green color is the water. This water level has to be maintained, mandatory. If the water level is not maintained, the water level will go down, it will drain down, and there will be a free access for the gases to go back to the engine room. So when the inert gas system is not working, out at sea also, this level has to be maintained. And that's why you have seawater pump. Two seawater pump must be there. If one stops working, the second should be able to start. One should be standby pump and one should be working at all times, 365 days a year, all the time these pumps are running, maintaining the water level in the deck seal. Now we understand under no circumstances we can allow these cargo vapors to go to the safe area. Now we know why. So under no circumstances that this water level should go down. So this water level has to be maintained day and night, whether you're alongside or you're loading or you're discharging or you are out at sea. These pumps must be working at all times, and these pumps are also connected to the UMS alarm. If it stops working in the night, also the alarm will be activated and the engineer has to go down and start the second pump. The water level has to be maintained. There is an overflow line there that water will keep overflowing, going to the sea, going overboard directly. But this pump must be running at all times to maintain the water level in the deck seal. Because as we know, mechanically operated non-return valve will leak. Not today, maybe tomorrow, not tomorrow, maybe day after. Someday it will definitely leak. So we cannot trust on this isolation valve, this non-return valve. So only thing we are banking on is the deck seal. And to maintain that, we have to keep the water level at all times. That is why it is important to maintain the water level in the deck seal. That's why SOLAS also says there should be two pumps must be there to give you the supply. One should be standby, and in case one fails, other should be able. You should be able to start the other one.
Sir,
But
why we keep the water recirculating in the deck seal? If I fill the water at the certain level, then also it will see in the web. So why we keep recirculating the water?
we are not recirculating the water. We are just supplying an overflow, going over. This is seawater. And why? Yes, you are right. You just fill it up and maintain like this. But with
Yes.
time, what will happen? The water will evaporate. Depends on where you are, and we may not pay attention. The level might go down. If you are in a very hot area, the chances that water level will go down due to the evaporation and all. So to avoid all that, there should be a continuous supply of water, and the level has to be maintained because we cannot, now we understood, under no circumstance we cannot afford to have these water level go down.
Yes, sir.
And definitely the vapors will enter the engine room and you have a fire and followed by explosion.
Okay, sir. Thank you.
Okay, that's why SOLAS says there should be two non-return devices, and one of the device should be a water seal. The purpose of the deck seal is to act as a non-return valve, as not to allow the cargo vapors from the cargo tank to go to the engine room, or vapors from the hazardous area to enter the safe area.
Deck seal with heating, what does that mean?
Yeah, deck seal with heating, you have, suppose you're going to the extremely cold temperatures somewhere in Norway or somewhere, and you're going inside the river. In the river, if it's badly snowing or something, in the river you will see, usually in the river you have fresh water. So fresh water can freeze. So these pumps will be putting the fresh water in the seal. It might freeze, it might become ice. If it becomes ice, and if you're going for discharging, your IG will not pass through this, go towards the cargo tank. You will not be able to run the IG at all. It will not go to the cargo tank. So this water has to be in a liquid state at all times, right? So in extreme weather, in extreme freezing conditions, heating coils are provided in the deck seal to keep it in a liquid state, to avoid it to form ice. So when you're in extreme cold conditions, these heating coils must be kept on and keep the temperature, keep the water in it warm or maybe ice free. That is the purpose of heating coils in the deck seal.
So these deck seals are mandatory for all the tankers or specified?
Mandatory for all the tankers where you have the inert gas system like this. If you have some ships, they have a IGG, inert gas generators, and there's a inert gas generator rooms which are outside the engine room, not connected to the engine room at all. In those cases, you can avoid deck seal. But otherwise, if you have an IG system like this, the flue treatment plant, you have to have a deck seal. And if your IG generators are also installed in the engine room, then again you have to have deck seal. The idea is you cannot allow these vapors to go to the engine room under any circumstances.
Sir, in my previous vessel, the IG generator was in the engine room, but there was no deck seals. The IG generator has a separate place, but it doesn't have deck seals.
Correct. So if it is a separate place, totally isolated, then you need not have to have deck seal. That's what I said initially. Okay. Otherwise, if it is in the open space in the engine room, then you have to have the deck seal unit. Okay. All right. Okay. We stop it here.
So, is there any regulation or is it stated somewhere like which type of deck seal to use on which type of vessel, or we can use any type of deck seal like?
Any type of deck seal on anywhere. It depends on ship owner, not on the
Okay.
SOLAS. Because all three types of deck seals are serving the same purpose. It's not allowing
Yes.
it's acting as a non-return valve only. It doesn't have any other function. Okay. So any deck seal can be used. They don't put the condition that whichever ship owner is up to the ship owner, whichever one he wants.
Okay.
All right, guys, we stop it here. Any question? Whatever we have discussed so far.
So, will we be discussing about this type of deck seals?
Yes, we'll be going in detail on that.
Okay.
We'll be discussing all three types with the proper diagram and all. We'll be doing that.
Okay.
So for the IG generators, only one NRV is sufficient.
If the deck seal is not there and if it is in the open space, on one NRV, mechanically operated NRV is also enough.
So then what it differentiate between the generator and a plant? Means plant is having deck seal for that same purpose, and here it is not.
Because IG generator is in the open space means it has its own room and it's not connected to the engine room perhaps, and it's not having a hot area. You're not doing any welding or it's not a common area. It's not connected to the, you're not doing any fire or any boiler is taking place. So in such cases you just need, usually you have inert gas generators for topping up purposes. So if it is protected, if it is in the safe area, you need not have to have deck seal unit. Okay.
Sir, in gas carrier also it is mandatory.
What's that?
So the deck seal in one non-written valve.
But yeah, I have no knowledge about the gas carriers. I don't think so there. It should be there because they are all pressurized tanks. So there are special gases. Flue gases are not used in gas carriers. This is my opinion. So they have this inert gas stored in the tank perhaps. And these tanks are in the gas carrier. These tanks are totally sealed.
Yes, sir. We did not have that deck seal system. Only
Correct.
just
So this IG, so in my opinion, should not be there because you need you have a very high pressure out there in the tank.
Yes, sir. We don't have this one
Correct.
on gas. We
That's
don't have.
right. You don't have. This is only for the cargo, for the chemical carriers and crude carrier or product carriers, not for the gas carriers.
Yes, sir. Also PV valves, all these things we don't have on gas carriers.
Correct. They shouldn't be there because you maintain high pressure. Those, the gas carriers, the cargo is carried in the liquid form because of the pressure. They generate so much pressure, these gases, they change into liquid state. And you don't have these PV valves, and those tanks are designed to take, those cargo tanks are designed to take high pressure in the gas carriers. So I don't think you will find all these things in there.
So we don't have PV for the tanks, but we have PV for the hold spaces because we fill the IG in hold spaces.
Okay, because the hold spaces are not pressurized, right?
Yes, sir. We filled IG in that hold space.
Okay. So whoever asked this understood now?
Yes, sir.
Any other doubt? Anyone? Okay. So far we have completed the engine room, the safe area side. If you refer to the diagram, the purpose of the last slide was gas regulating valve. So we know the use of this, why this gas regulating valve is there, and how does it automatically operates and maintains the pressure in the cargo tank as set by the operator. And if the oxygen percentage is more than the required, it doesn't allow it. This valve also functions and doesn't allow the high percentage oxygen inert gas to go towards the cargo tank. So after this regulating valve, the IG main pipe enters the deck area, the hazardous area. You have the hazardous area and the safe area. This was the safe area. Engine room side till the regulation side is a safe area, and it enters the hazardous area where all the restrictions are enforced, are applied. So once it enters the deck area, there should be 2 non-return devices must be installed in the IG system. Non-return devices meaning there should not be a gases going back to the engine room. So that for that purpose, These non-return devices must be installed, one of which shall be water sealed and shall be fitted in an inert gas main supply. So there should be two non-return devices, one of which should be water sealed. This device shall be located on a cargo area, as already mentioned, and there should be a two separate pump supplying the seawater supply to this water seal to maintain the water level in the deck seal. Two separate pumps must be there. One should be standby and one should be running, and to maintain the level in the deck seal, seawater level in the deck seal. Because of the water only, it's forming the seal, so the water level has to be maintained in the deck seal. We'll be discussing this in detail in the later part of the IG system. The water seal shall be such that it will prevent backflow. As we have already mentioned many times, the main purpose of the deck seal is to prevent backflow of the hydrocarbon. So for all these purposes, and this water seal gives you the 100% guarantee. Though the mechanically operated NRV, non-return valves, with time and with the age of the vessel, there are chances that this valve will start leaking. Maybe a small quantity, but definitely it will start leaking. Those who are from tanker, those who have done this maintenance on this NRV, they must have seen a lot of pitting areas are formatting with time. A lot of pitting on these valves. It's because of the acidic nature of the inert gas. It eats up the material. So because of this pitting, the chances that with time these valves will start leaking. So you cannot depend 100% on this mechanically operated NRV. That's why the water seal is provided. Irrespective of age and time, this water seal will maintain the seal. It will definitely not allow any, even a small quantity of the vapor gases to go towards the. So the water seal is more reliable than the non-return valve. And for that purpose, two separate, so more concentration is given on the deck seal. Two pumps are there only for this purpose, so that the water level can be maintained. And if the one pump fails, other pump will, this is connected to the UMS alarm also. The alarm will come to the engine room, and some engineer has to go down and start the other pump, and repairs has to be done on the first pump. So it is so important to maintain the seawater level in the deck seal, because we cannot afford these cargo vapors to go towards the engine room, safe area. As we have already discussed, explosion and fire can take place if we allow this cargo vapors to travel all the way back to the engine room or boiler uptake. Now, the ships are going from, they are transiting all the areas. If they are going to the freezing, extreme winter areas and transiting through the river, there are chances that this water in the deck seal will freeze. So if the water freezes, IG will not go through the, you will not able to pass this inert gas also to the cargo tank. So to avoid this freezing of this water, heating arrangement is also provided in the deck seal. Even SOLAS also requires that provision shall be made to ensure that water seal is protected with against the freezing in such a way that overheating does not impair the integrity of the seal. So that in extreme weather conditions, extreme winter weather conditions, the water in the deck seal remains in the liquid form rather than changing into the ice. So that heating arrangement has to be provided. Second seal shall be a non-return valve that shall be provided with a positive means of closure. One seal is a water seal, second is a normal non-return valve, must have a closing devices. Also, you should be able to close that valve in case required for maintenance or for sailing purpose. Also, out at sea, you can keep it closed also. So the provision has to be provided as per the SOLAS. Now comes this is for discharging. Whatever we have discussed, this requirement are all for discharging. When you are discharging the cargo, that vapor, the vacuum that is created in the tank has to be refilled by the IG. And this is what so far what we were discussing from the boiler till the deck seal or till the NRV is how the requirement must be there for the IG to be supplied to the deck. Now, if we are loading in the tank, if you're loading cargo in the tank, the vapors in the cargo tank has to be vented out. So the venting arrangement from each cargo tank has to be provided on the tanker. So the same IG system, IG line, which has come till NRV, continues and goes from aft to forward. Main IG line is provided, and you have a mass riser in the forward section of the IG main. And from there, a branch IG is going to each tank with a valve associated with this, like this. This is the deck seal NRV area, and after that, this pipe is going in a 4.5 direction right till the forward. And there you have a mass riser, and these are the branches which is going to the each cargo tank with the valve here, which call it branch IG. It's been branched out to each one pipe is laid down to each tank. So when I'm loading in any particular tank, the vapors from the tank will come out from this branch IG, join the main IG line, and from the mass riser it will be vented out. So, and when I'm discharging, IG supply is coming from the engine room and going, as you are discharging, it's entering to the tank, and all the vacuum space, air, the space in the tank is replaced by the inert gas, which is supplied by the from the inert gas system. And when I'm loading, the same vapors comes out using the same pipeline, and it's vented out to the atmosphere. So SOLAS says the venting arrangement has to be there. The arrangement for the venting of all vapors displaced from the cargo tank during loading and ballasting shall comply with the regulation 59 and shall consist of either one or more mass risers. You have, I've shown you one mass riser, and or a number of high velocity vent. You can vent it through the mass riser with the common line, common IG main line with the branch IG going to each tank, or otherwise you can have a high velocity vents on each tank as per the requirement. So we can vent it out. It's not a mandatory that you have to vent it out through the mass riser. You can have, the option is given by the SOLAS to the ship owners to install the PV valve or high velocity valve instead of mass riser. So PV valve has to be installed in each tank for venting purposes. So when you are loading, these vapors have to keep this PV valve open. If this mass riser pipelines or branch IG lines are not there, which is the case in chemical tankers, we don't have mass riser in the chemical tankers because we cannot, when you're carrying chemicals, you cannot afford these chemical vapors also to react with each other. So the chemical vapors from one tank should not come in contact with the chemical vapors of the other tank. That's why this common line is not there, not used for venting purpose. Whereas in crude carrier and product carriers, we can use this common, because when the vapors are from the, usually we are carrying the homogeneous cargo, one grade only, or maximum two grade, but most of the time single grade. So contamination of vapors and all doesn't carry any value. So we can use the common line and vent the whole vapors from all the vapors from mass riser. But in case these vapors,
last line says IG, sir. Last line says IG supply mains may be used for such venting, which is what you explained, that we can shut off the IG deck isolation valve and use the main line for venting through mass riser.
That's right. This is the IG main. This is what it is referring to. This is the IG main.
And the
or
next is,
if you have a,
yes sir, yes.
Go ahead.
So the next query is, if the ship is a type 2 or 3 chemical tanker carrying sometimes petrol or diesel or sometimes some cargoes which are allowed, it is allowed to carry. In that case, we can vent one particular tank which is having one grade of cargo at a time. Means we can vent separate cargoes at separate times.
Correct. You can do
the mass riser, if there is a provision of a mass riser there on that ship.
If you have, okay, if you have the provision of the mass riser there, then the other grade IG valve has to be shut.
Yes, sir.
You have to be absolutely sure that these valves are shut or not leaking.
Yes.
If the vapors are reactive to each other, so you're taking too much risk. So you have to be absolutely sure that these valves are. You have to close these valves first and foremost. Secondly, you have to be absolutely sure that when I close these valves, they are not leaking.
Pressure in the adjacent tanks is not increasing.
Correct. So when I'm venting it out, in such cases, I can vent it out through the mass riser. Okay. But we have to be absolutely sure the tanks which I'm not using, the contamination should not take place. Contamination of the vapors also should not take. If they are reactive, it might react or create a exothermic reaction and generate a lot of heat or something like that, like it happens in chemical. So in such cases, it can bring a dangerous situation. So to avoid that, we have to be absolutely sure. We have to be absolutely sure that these valves are holding. So best way is vent it out through the PV valve. In such cases, you are absolutely sure you don't have to bother whether these valves are holding or not, whether these vapors are going inside this other tank which are not supposed to go, like in chemical tanker that we do.
Yes, sir.
But yes, if the provision is provided, yes, there is a way of doing it. You shut all the IG valve, branch IG valve of those tanks which are not to be discharged, not to be loaded, and then you start loading in the other tanks and vent it out to the mass fiber. Okay?
Yes, sir.
So that is the requirement for or instead, in the same, each tank here you can have PV valve corresponding to each tank. You can have PV valve in the middle of the tank and high velocity valve or PV valve. In case when you're loading, the vapors can be emitted from the PV valve. That is also allowed by the SOLAS. So you can have this system or PV valve system, but most of the ships, crude carrier or product carrier, they have both. They have PV valves, they have primary venting system in the form of IG line, main through the mass riser, and secondary venting system it looks like this. Under pressure it is coming out from there, and under vacuum, if there is a vacuum, the air goes from here, and it is installed like this. It is installed on top of the tank, is open to the PV valve. Okay, so if there is a pressure there, the pressure can be released from the PV valve instead of the mass riser. That is a secondary way of venting.
Okay,
sir. Excuse me, sir. I had another doubt. When we were doing VEX loading, we also so there was a small confusion regarding whether the alarm system is considered as one of the primary or secondary venting barriers.
Yes, it does. The alarm system, pressure alarm system, the pressure indicators which are coming in the cargo control room.
Yes, sir. Which is set at 90% and 10% less and more.
Correct. Those are also considered secondary venting system because it's giving you the alarm.
Right, sir. So it is considered as secondary venting.
That's right. It is. So that's why they have made it a mandatory requirement to install all these alarms also.
Yes, sir. That's
tech. Yes, it is a secondary venting system.
Right, sir. Thank you, sir.
Right. Okay. So if the connection, any other doubt before I proceed further? Okay. So any arrangement for venting of all the vapors displaced from the cargo tank during loading and ballasting shall be complied with. So we have already covered this. So there should be a venting system for release of the vapors while loading. Okay. If a connection is fitted if there is a connection between the IG line and the cargo line, which is there in most of the ships, if the connection is there, then there should be a separation with the two valves. Connection should be there with the two valves, and in between these two valves there should be a vent. This is the SOLAS requirement. If there is a connection, so that the oil from the cargo line should not go into the IG line. If the oil goes to the IG line, the chances that this oil will go into the deck seal will be full of oil, right? And these vapors can go to the engine room and create a havoc on board. So that's why if there is a connection between the IG line and the cargo line, there should be connection should be with the two valves. Some ships, they are putting a blank also in between, spectacle blank, so that you have to change the spectacle blank with the two valves, and also in addition to that they have a vent. Okay, so that you're absolutely sure the oil should not leak into the IG line. The idea is that. Any doubt about this diagram?
Sir, that blank which is placed between those two valves is considered as venting arrangement?
No. Which two valves?
Sir, like in previous slide, it was told that when IG system is connected through cargo piping system, then there should be two valves and one venting arrangement.
No. So the idea of the vent is to keep checks. These valves should be shut. These two valves should be shut, and there should be a vent in between these two valves. Vent means is a gooseneck kind of a thing. So that when you open this valve, just to check, there is no oil in this between these two valves. There is no leakage, no oil or no IG in there. So that means this is the way to check these valves are shut and they are holding, they are not leaking.
So that vent gooseneck type should be in between those two or on the either side.
in between these two valves, so that we can check this section between these two valves. We can check this section. The oil is also not leaking and the IG is also not leaking. The vent should be there, the vent with the valve also. So you have to open the valve and see no gas or no oil is coming out from those vents. Let me see if I can show you with the diagram. Just give me a minute. Okay, I'll come back on this diagram. Give me some time, I will explain it later. I cannot find the diagram anywhere. Okay, I'll share this slide with you, just a minute. Okay, you see this line? This is the deck seal here, and this is the IG line going forward. And here is the connection between with the cargo line. And you see this one valve is here and one more valve. There should be minimum two valves, and this is the IG line and this is the cargo line, and they are connected together with the two valves and a vent in between that. Is that clear?
Yes, sir. I was on
Yes, sir.
product tanker, sir, and this type of arrangement was made near the manifold, sir. And there were two valves, and in between there was one blank. So I was just asking because there was no vent, sir. So I'm asking whether that blank is considered as that venting arrangement or for checking the
It
purpose.
should be, the last requirement is this is the way it should be with the vent has to be there. In addition to these valves and vent, you can put a blank also. So these are the minimum requirement as per the SOLAS. You cannot change that. In addition to this, you can put a blank. So what people do is they put this two valves, they put a vent also. The idea of the vent is to open these vents and see anything is coming out in this small section or not. If you see IG is coming out, that means the IG valve, this particular valve is leaking. If you see oil is coming out, that means this particular valve is leaking and need to do something. That is the idea. And in addition to that, people put a blank also. As I told you, if these two valves are leaking, oil can go in the deck seal. This is the deck seal here.
So both these valves are NRV or like normal butterfly valves?
No, these are all normal butterfly valves. There is a valve here. You can close, and there's a gearbox here. You can see that at the bottom.
So like
These are
we
all
were
normal.
having only one deck seal and one NRV. We are not having like this kind of arrangement.
That's okay. That is okay. See, this is deck seal, and this is a non-return valve somewhere. Maybe here you have a non-return valve, and that is going further up. And this is the connection to the cargo line. IG line, between the connection from the IG line and cargo line.
Okay, so this was there near manifold. We had one spool piece and this kind of.
Correct. You can have a spool piece also. You can remove the spool piece and blank it.
Okay, sir. Okay.
So that is that's how the venting arrangement. If there is a connection between cargo side and the inert gas line, the arrangement as per the SOLAS should be like that. There should be two valves, and in between the valves there should be a vent. This is the minimum requirement. You can add more. You can put one more blank also. Many people are doing that. Many ship owners have done that. And in addition to that, if you now, since we are on this diagram, those who have worked on the tankers, you must have seen a vent here also, a gooseneck kind of a vent here also, just before it enters the engine room.
Yes, sir.
Breather valve. There's a vent here which is open when the IG system is not working, and it is closed when the IG system is working. So what is the purpose of that vent? Is suppose your deck seal does not work. Suppose there is no water in it and still somebody has bypassed that alarm. So alarm also did not activate. So the vapors from the cargo side will go towards the engine room. So there is another device provided which is open. The vapors will come out from here. It's another safety device installed in the system to avoid the cargo vapors to travel backward. Many ships, they have that vent also. If you're not seen, next ship when you go, for the people, those who are working in the tanker, check for this vent. It is there or not on board.
So we are also having this one breather valve, this near the mast riser. Like it's also serving the same purpose?
No. That breather valve is not for that purpose. That breather valve is when there is excess pressure in the cargo tank, and your PV valve.
We had this manual valve, so it's of like that. Like you are telling excess of pressure, then this PV breaker will be activated, no sir?
Suppose you have excess pressure in the tank. Your PV valve is supposed to lift first. Suppose it does not lift, then your PV breaker is supposed to lift. If that also doesn't work, then you have another safety device in the form of breather valve.
And this PV valve was same.
and this PV breaker was higher, as it's not mechanical, so like it will work efficiently. That's the main purpose it's serving. Like sometimes these PV walls are not working because they are mechanical, but in this PV breaker nothing is mechanical, like what Chief also told you.
So it depends on all three. These three systems are set at certain pressure. If this not work, if this safety device does not work, second will work. If this not work, third will work. So many safety devices basically are installed in the system. It's not necessary that PV breaker will work. If the water level is not okay, if we have filled up water, too much of water, we don't know where is the marking supposed. And many times it happens on board. People don't know how much water to be filled up in the PV breaker, and they fill it up too much. Then when you put too much water in that, it will not release at set pressure. Understanding what I'm saying?
Yes, sir.
So when it is not working at set pressure, then the pressure will keep increasing in the cargo tank. So to avoid that, another device is installed in the system in the form of breather valve. Some ships they have a breather valve setting more or less same as PV valve. Some places you have the breather valve setting more than the PV breaker also. So it depends on ship to ship. But the purpose is to release the excess pressure from the cargo tank.
Okay.
So this diagram is understood?
Yes, so this PV valve and PV breaker are same thing?
Any doubt remaining? Okay. Venting arrangement has to be there. Now they're talking about PV breaker. One or SOLAS requirement is one or more PV breaker, pressure vacuum breaker devices shall be provided to prevent the cargo tank from being a positive pressure, excess of positive pressure of the test pressure of the cargo tank. If the cargo were to be loaded at a maximum rated capacity and all other outlets are shut. A negative pressure in excess of 700 at water gauge. If the cargo were to be discharged at a maximum rated capacity, inert gas blowers were not working. If you look at your diagram, that one we have drawn, this is the PV breaker, we'll be working on this in detail. How does it work? This PV breaker is connected to the IG main line, and this IG main line is connected through the branch IG valve to all the cargo tanks, as we have seen in the venting arrangement. So if the pressure keep on increasing in the cargo tank on the positive side, and there is no release mechanism open or is not functioning properly, at certain pressure, at the set pressure, the PV breaker all the water will be released from the PV breaker, and the excess pressure will be released, all the pressure will be released from the PV breaker. So that is the purpose of the PV breaker, to avoid excess pressure in the cargo tank, excess positive pressure and excess of negative pressure, to protect the cargo tank from any damage. So as per the SOLAS, what does it says? PV breaker is connected somewhere here to the main IG line. Anywhere it's connected to this main IG line and it's installed on deck. Okay, so at certain pressure, and this main IG line is connected to all the tanks to this branch IG line, and these valves are always kept open and locked. So if there is too much of pressure in the cargo tank and none of the openings are, and if suppose masterizer is shut, this PV breaker will release the pressure at certain set pressure, usually is around 1800 to 2000 at water gauge. At that such pressure, it will release all the water all the water will fall into the deck, and there will be an opening. All the excess pressure, all the cargo vapors will be released through PV breaker. In such a way, the cargo tank will remain intact and protected. That is the purpose of the PV breaker. And same happens on the negative side. If there is a vacuum generated in the cargo tanks, and if it is more than 700 minus 700 at water gauge, in the negative, the water will be sucked and there will be an opening for fresh air to enter through the PV breaker and break the vacuum in the cargo tanks. So PV breaker is a requirement. One or more PV breaker devices shall be provided to prevent cargo tank from excess pressure or excess vacuum. Such devices shall be installed in inert gas main unless they are installed in venting system required regulation 59.1 or on individual cargo tank. Usually it is not installed on individual cargo tank. It is installed on IG Mean shall be provided for continuous indicating the temperature and pressure of inert gas at the discharge side of the gas blower. So there should be a temperature, what temperature the inert gas is coming out from the IG blower, and what is the pressure of inert gas on deck. These indications must be installed in the system as per the SOLAS requirement. Okay.
Sir, earlier you said, sir, that in case of excess negative pressure, the water will be sucked and air from the outside atmosphere will come in.
Correct.
So the water will enter the IG main, and through IG main they can enter cargo tank.
That's right. It will go in the cargo tank. Not much of a water, not even 200 liter of water. That water will go in the cargo tank, and the air will go. Once the opening is provided, when the all water has gone in the cargo tank, there will be an opening, then and it will break the vacuum. All air will enter. It is air from the deck. It will enter through the PV breaker, will go in the cargo tank, and the vacuum pressure will be brought down to zero pressure.
Okay, sir.
Okay.
सर ये सिर्फ IG मेन पे ही इंस्टॉल होगा.
IG main पे ही install होगा. As you can see in the diagram also, no, it is connected to the IG main.
तो सर अगर कोई भी टैंक में ओवर प्रेशर होगा या नेगेटिव प्रेशर होगा तो मतलब जो जितनी ब्रांच लाइंस होंगी सब में जाएगा एयर, ऐसा कुछ होगा?
देखो ना what will happen. एक में तो होगा नहीं, because these all valves are open all the time. All valves are all the time open. So the whatever pressure is here, the same pressure will be there also. If there is a negative pressure, so all tanks will have a negative pressure. You understanding what I'm saying? If there is a too much of pressure in the tank, all tanks will have the same pressure, because this is all common. They are all commonly connected with the IG main. They are all connected together, no? So
Yes,
IG pressure will be same in all the cargo tank, whether it's positive pressure or negative pressure.
Okay,
so that
sir,
is why
now I
understood. That is why it is installed. It is connected to the main line, because all pressures are the same. So once the water is, suppose in the vacuum side, if the water is released, or water is sucked into the cargo tank, it might go to any cargo tank, doesn't matter. But the idea is the air will definitely go in all the cargo tanks and bring the vacuum back to the zero.
Yes, sir.
Okay, and same goes to the pressure side. All cargo tanks will have a high pressure. If there's high pressure, all tanks will have high pressure, and this is connected, as they are all connected, commonly connected to the IG main, right?
Yes,
so once there is excess pressure, at certain pressure, all water will be released on deck from the PV breaker, and once there is no water in the PV breaker, there will be an opening. So all the pressure from the cargo tanks will be released through the PV breaker, and it will come back to the zero.
Yes, sir.
Okay, that's how it works.
Okay, sir. Thank you.
Right. So these were the SOLAS requirement for inert gas system. Not only these, there are some audio and visual alarms also fitted in the IG system to protect the system and also to protect the cargo tank. And some of these audio and visual alarms, when they are activated or when they get activated, brings the total shutdown. It shuts down the system till the alarm is corrected, till the alarm is removed or the error is removed. The purpose why it is shut down, because it protects the system, to protect the system, and as well as protect that atmosphere in the cargo tank also is maintained. So following are the various alarms with the shutdown incorporated in the inert gas plant on board. With the shutdown, when these alarms are activated, it will shut down the system, IG system. It will shut down the blowers. Like high level alarm in the scrubber. When this alarm is activated, it will shut down the blower till, and you will not be able to start this system till the water level, high level water level is brought back to the normal, when till this alarm is eliminated or this error is corrected. Another is low pressure seawater supply to the scrubber. If the pressure is not sufficient by the scrubber pump which are supplying the seawater to the scrubber, if the pressure is less, alarm will get activated and will trip. Another one is low pressure seawater supply to the deck seal. As we just talked about, deck seal also has a continuous water supply, seawater supply, to maintain the level. If the pressure reduces there also, alarm will get activated, and if the IG system is running, it will trip the system. The alarm is corrected again, the error is corrected again. Then we will able to start the system. Another alarm, high inert gas temperature. If the temperature is 70 degrees or around, it will trip the system. Hot. The gases which are coming out from the scrubber tower are very hot. If they are around 70 degrees, it will stop the blowers. It will trip the blowers. It will shut down the system till the temperature of these gases are brought down to the close to seawater temperature. Low pressure in the afterblower. Low pressure in the, when there is a IG pressure is less than 250 mm water gauge and IG blowers are not coping up properly, it will trip the system. Low level in the deck seal. See, so many safety devices, so many alarms are installed in the system to protect the system and to bring the safe atmosphere in the cargo system, cargo tanks. Low level in the deck seal will again lead to shutdown. If there is a power failure, it will shut down. And if there is an emergency stop also, if somebody presses the emergency stop, it will shut down the system. So these are the alarms with shutdown installed in the IG system. Whereas there are some alarms, they are just alarms, audio and visual alarms, but it will not shut down when these alarms are activated, it will not shut down the system, it will not stop the blower. These indication will keep on coming till these alarms are corrected. For example, scrubber low level, deck seal high level, low O2 content if it is 1% and less, high O2 content if it is more than 5%, the alarm will come, but it will not shut down. And lube oil pressure, oil alarm. So these are the alarms installed in the IG system. Some of these alarms are the shutdown and some of these alarms are just the indication with the audio and visual alarms. And once they are corrected, but it will not shut down the system. Okay. Possible source of inert gas, it can be through the auxiliary boiler, it can be independent IG generator, or it can be in the form of gas generators, gas turbine fitted with the afterburner. These are the three sources you can have it. SOLAS also permits all these three sources of inert gas can be there on board. Okay. All right. So I want you people to draw. This is the actual diagram which is there on board, inert gas diagram, how it is installed on board. So in exams, if you have this IG system to be, they ask you to draw the diagram, you have to draw this diagram. The one diagram we drew in the beginning of the IG system, that is only for the explanation purposes, and this is how it is actually installed on board, the full IG system. So please draw the diagram for your examination point of view. Thank you. I'll give you 5-10 minutes.
So can you just show the previous slide?